So Craig, what product do you oversee?
I'm the product manager for the non-volatile memory products here at Zajac.
Talk about non-volatile memory versus some of the other kinds of memory.
Sure. So at a very basic level, non-volatile memory is memory that keeps its contents even when you turn the power off. So it's different than Zajac traditional SRAM technologies, where they actually lose their data contents when you lose power. So you compare our embedded technologies to traditionally embedded E-squared or embedded flash that's very common. What makes the Zajac offering different is we do it all in a standard CMOS process. So we have embedded reprogrammable non-volatile memory that runs in standard CMOS. So it's a single poly process, no extra masks, no extra process steps, which is different from a lot of the traditional embedded non-volatile memory technologies that use a significant number of mask steps to create the NVM bit cell.
Why is that necessary in the market versus some of the other kinds of memory? What does that do versus the volatile memories?
Well, so our portfolio allows our customers to do a few things. Number one, for a lot of applications, external E-squared chips that are all over the place, it allows you to integrate that functionality into your SoC. So particularly if you're looking at wireless devices or small consumer electronics, you save the system area, you save power, you actually save cost in being able to integrate the E-squared functionality on chip. And for some other markets, having reprogrammability embedded in is a requirement. The RFID market's a perfect example, where the standards mandate that you have reprogrammable NVM embedded in your tags. And then the last thing that we see a lot of, the last two things really, is first for encryption keys, to being able to embed and update encryption keys. And then the big trend we see now is for a lot of precision analog, MEMS sensors, silicon clocks, DACs, ADCs, where the need to do configuration and trim settings, you want to do it multiple times, either over multiple temperatures or do it at wafer sort, then post-package, or even in system, so that you can optimize the performance of your analog components.
So has this traditionally been very vertical market oriented?
Standard CMOS-based non-volatile memory, it's actually been around about a decade between Zajac and Impinj, who Zajac acquired a couple years ago. And just now, it's really starting to grow and get more and more traction. There's a lot of big markets. The automotive market's a big driver that's starting to look for reprogrammability in a lot of their trim. So we've actually just recently qualified the first embedded MTP that meets the automotive AEC Q100 standards. We're also starting to enable capabilities at process nodes where reprogrammable non-volatile memory was never available. If you look at a standard flash, it's really commercially available down to about 0.13. A year ago, we qualified down to 65 nanometer at TSMC. We've moved the technology to a place where it's opening up markets for wireless SoCs. It's opening up markets really where there was no option to do this before.
Is there a pain point on the customer side that has to be met as well that this is starting to fill? So
the customers look at it in a couple different ways. For some of them, it really is a cost, power, area reduction because they already have this off-chip, and they're looking to integrate and improve the performance. For some other customers, it's adding in features or capabilities. And so it really the way we've been successful is we get engaged with a market leader. We've got a long list. You've got SanDisk, we've got Analog Devices, National Semiconductor, Silicon Image. So there's a broad range of companies who are leaders in their space who kind of set the bar and set the expectation. And once the expectation is set that this capability and feature set is available in a particular target area or product application, then everyone else starts to follow. So we're seeing more and more pickup in a broad range of applications as we engage with more leading edge companies.
Is it only at the front edge of Moore's Law, or is it starting to pervade even some of the older technologies too?
So with the NVM technology, there's actually a huge market back at the analog focus nodes. And one of the things that we see happening for a lot of the precision analog, and we've talked about sensors and we've talked about silicon clocks, is a lot of companies who have traditionally been internal at 0.5 or 0.35 micron are now moving to a fab-lite strategy, either at quarter micron or there's a huge push at 0.18. And they're looking for this capability in the foundry market. So we've actually done a lot of work over the last 12 to 18 months investing in New market-specific products for RFID, for analog trim, really all focused around 0.18 and 0.13. And that's gone in parallel to our drive to get to 65 and 40, and we've actually started work on 32 as well. So we're serving both the analog markets as well as the leading edge.
Craig Zajac, thank you very much.